Let's discuss, depending on the values of the parameter a, the system that we see on the screen. We can see that the system has three unknown values, x, y, and z, and a parameter a that multiplies the z in the third equation. Depending on the value of the a, we will have different solutions for the unknown values, and the system would be of a different type. Let's write the system as if it were a matrix. Using Gauss's method, what we have to do is to simplify the system. So we begin writing the system as a matrix, so it would be 1x plus 1, that's y, minus 3z equal to 2. Just have to write the coefficients of the letters. So doing the same with the second row, and with the third one it would be minus 1, 3, a for the z, don't forget about that, and 2. And now what we have to do is multiplying rows and adding or subtracting rows. We have to find zeros. So the second, let's multiply the first row by 2 and add it to the second row. So the first row would stay the same, that is 1 minus 3, 2, and now multiplying the first row times 2 and adding it to the second row, we would have minus 2 plus 1 times 2 is 2, that is 0. 1 times 2 is 2, plus 2 is 4, and minus 3 times 2 is minus 6, plus 1 is minus 5, and 0 times 2 is 0, plus 2, I'm sorry, 2 times 2 is 4, plus 0 is 4. And now let's multiply the first row times 1 and add it to the third equation or row. That would be 0, 4, minus 3, plus a, don't forget about it, it's very important, and 4. We still have another step left. We have to make another 0, so let's multiply by minus 1 the second row and add it to the third row. So this would be, the first row will stay the same, it would be 1 minus 3, 2. The second one stays again the same, because it is the one that is gonna be added or subtracted. So now let's go with the third row, that is 0 plus 0 times minus 1 is 0, 4 times minus 1 is minus 4, plus 4 is 0, minus 5 times minus 1 is 5, plus minus 3 plus a, it's equal to 2 plus a, and now 4 plus minus 4, 0. Now we're done with this. Using Roche-Frobenius theorem, we have to take a look at the system of equation that we had at the beginning and compare it with the one we've obtained, and we can see that they are equivalent systems. We would obtain the same answers for the unknown values in either of the systems. So let's call this matrix inside here the matrix A, and the matrix with the 4 columns the A star. Let's write down here the matrix A. We can see that it is a 3 times 3 matrix, So let's calculate the rank of this matrix, and the rank of this matrix depends on the values of 2 plus a. So if 2 plus a were different from 0, that means that a is different from -2, the rank of the matrix A would be equal to 3. That is perfect. Let's write it up here so we don't forget it. That is, the rank of A is equal to 3, and therefore the rank of A star would be again the same, because A is a submatrix of the matrix A star. So the rank of A would be always be smaller or equal than the rank of the matrix A star, and the minimum rank of the A star would be 3, and that is because it has 3 rows. So the rank, as the ranks are the same, let's write it up here, and that means that as we have 3 unknown values, x, y, and z, and the rank of A is the same as the rank as A star, this system is a compatible determined system, and that means that we have an exact numbers of solutions. I mean, just one possible solution for the system, for one solution for every unknown value of our system. Now let's go with the other option. If A were equal to -2. If A were equal to -2, having a look at the matrix A, we have down here, we can see that in the last row the 2 plus A would be a 0. So the rank of A would be equal to 2. And in this case, I'm gonna write it down here. The matrix A star, if A were equal to -2, would look like this, with the last row full of zeros. So for the rank of the maximum rank of the matrix A star would be equal to 2, and that is the same rank again as the matrix A, because we have a row full of zeros. As the rank of A and the rank of A star is 2, is smaller than the number of unknown values, that is 3, would have an indeterminate system. That means that we would have an infinite solutions for our system. That means that each unknown value would have various possible answers for solving this equation.